Okay, we're going to start chapter 5, the laws of motion. Um, and, where's my, there it is. Bring up the PowerPoint. Now, we've been discussing, especially in chapters 2 and 4, how we can describe motion of objects. That's a study of kinematics. But now we're going to just describe what what causes those changes, what causes those accelerations, what causes those changes in velocity. And the answer is going to be forces. This is the area of dynamics. And we're going to start with the Newton's 3 laws of motion. So we'll get started here. Um, okay, we're going to talk about the concept of force. And in this graph, you see all of these blue arrows are a type of force. You have on the top 3, you have contact forces. The person pulls on a spring, and it causes a force. The child pulls the wagon, and it causes a force. The football player kicks a ball, and he exerts a force on the ball. These are all contact forces. Now, the bottom 3 are what we call non-contact forces. They come from field forces. Uh, in the figure D, you have the gravitational force of one object on another. In E, you have the uh, electric force, the negative charge being pulled towards the positive charge. And in F, you have the magnetic force. If you have iron, it doesn't matter whether you're pulling with the north pole or the south pole of a magnet, you're going to pull it together. If you were to happen to have 2 magnets and you put a north and a south together, you'll get quite a pull. If you try to put a north and a north together, or a south and a south together, you'll get a repulsion. There'll be a force that doesn't allow you to put these things together. Uh, so these are the difference between contact forces and field forces. So some of the fundamental forces that we have in nature are the gravitational force between objects, the electromagnetic force between electric charges, the strong force between subatomic particles, and the weak force that arise in certain radioactive decay processes. Right now, we're only going to consider gravitational forces, and in the next semester, we'll talk about electromagnetic forces. Okay. Um, Now, uh, we can use the deformation of a spring to measure force. A vertical force is applied to a spring scale, and we can see the spring elongates when a force is applied. And the pointer on the scale reads the extension of the spring. We can calibrate the spring by defining uh, reference force F1 as a force that produces a pointer reading of 1 centimeter. Now we apply different downward forces for F2 with a magnitude of 2F1. Um, so the pointer moves down to 2 centimeters if we double the force. We combine forces equal the sum of the individual forces. So if we have a force of 1 uh, that causes 1 centimeter uh, deformation, we add one that forces 2, we'll get a total of 3. Okay, 3 centimeters deformation. Okay, let's see. When when F1 is downward and F2 is horizontal, the combination of the 2 forces elongates the spring by 2.24 centimeters. What does this look like? Well, this looks like our vector problems that we studied in chapter 3. So if force F1 is applied downward and F2 um, is applied horizontally, uh, the pointer reads 2.24 centimeters. The single force F that would produce some reading is the sum of the vectors of F1 and F2, going back to our uh, vector uh, vector study. So there shouldn't be a one subscript on that F1. Um, Now, the direction, um, 1 unit of the magnitude of this force would stretch this particle spring by 1 centimeter. We must use rules of vector addition to obtain the net force on an object. Okay, this ends our discussion on the concept of force. Nice short little intro, and we will next discuss Newton's first law and inertial frames.